Good morning, students. So, in the previous sessions, we discussed about the laws of illuminations. Two laws, inverse square law and Lambert's cosine law. We discussed, and also we started with the problems on illumination and solved some of the problems also. So, in this class, we'll take a few more problems on the illumination laws of illuminations. Okay, and then we'll move further. Okay, then. So this is the question. So the lamp having 300 cp in all the directions below the horizontal is suspended 2 meters above the center of the square. Table of 1 meter side. Calculate the minimum and maximum illuminations on the surface of the table. They are asked. Okay, 300 cp lamp and it is suspended at 2 meters horizontal. Okay, the sides of the table is 1 meter. Calculate the maximum and minimum illumination. So the maximum illumination, so this is the table you can see. Okay, so 1 meter, the suspended at 2 meter. So this is 1 meter, 1 meter and 1 meter, the suspended at the 2 meters. Okay, so the maximum illumination will be at the center of the table, because so here we have a lamp, so the maximum illumination will be always at the center. Minimum illumination is at the corners of the room. Okay, so you have to calculate the maximum and minimum illuminations. Okay, so here the diagonals of the tables, so calculate the diagonals of the table. So diagonal is 1, so this is also 1 meter, 1 meter, so diagonal is, so 1 square is equal to root of 2, it is 1.44 meter is the diagonal. So if the complete is 1.44, okay, so half of this is 0.77, 1.44 by 2, it is 0.707. So this is 0.707 and this is 0.707. Okay, now you know this value and this value, so calculate this diagonal. Okay, using the same Pythagoras. So the height is 2 meter. Okay, then maximum illumination is at the center. So according to the inverse square law, so Cp divided by d square. Okay, so Cp is how much? They are given 300 divided by distance is 2 square. So you'll get 75 lux or lumens per meter square. Okay, this is the maximum illumination. So minimum illumination, so you have to calculate at the corner. So to calculate at the corner, once again you have to find out this diagonal value. Okay, how much is the diagonal value that you have to find out? So the square of this plus square of this will get this one. Okay, if you know this one and this one, okay, you can easily calculate this, right? See, so 2 square plus 0.7 square is equal to, it is both equal to square root of 4.5. okay, so this is the value of the that particular diagonal. Now cos theta is opposite adjacent divided by hypotenuse. So this here you have to find out cos theta adjacent divided by hypotenuse. So how much? It is 2 meter divided by hypotenuse is 0 square root of 4.5. So you know that inclined surfaces, the illuminations on the inclined surface. See here is the lamp, you have to calculate the illumination at this particular point. So inclined surface, so the second law you have to call Lambert's cosine law you have to use here. So illuminations using the Lambert's cosine law is Cp divided by d square into cos theta. Cp is 300, as you know, it is given from the problem. D square is the distance you calculated, it is square root of 4.5 square into cos theta is 2 divided by root of 4.5. So if you substitute all the values, you will get the illumination as 62.9 lux. Okay, that is the illuminations on the surface. So this is how you have to calculate the illuminations. Okay, now so the second is two lamps of 200 cp and 400 cp are arranged as shown in the figure. Okay, calculate the illuminations in the middle of the lamp. So this is the figure they have given, two lamps. So this is your lamp A, lamp B. So it is the distance between the two lamps. So height of the lamp B and height of the lamp A. So distance between the two lamps is 100 meters they have given. So you can see here the rewrite and so rewriting this dimensions. So it is a lamp A, lamp B. So 100 is divided by 2, 50 meter, 50 meter, 30 meter, 10, 15 meter. So the distance between the lamp A and the center, that means distance between lamp A and the center distance between the lamp B and the center you have to calculate, then you have to calculate the illumination. So the distance between the lamp A and the center P, so it is 15 square. So I think Pythagoras problem. So Pythagoras, that means, so 15 square divided by 50 square, you will get this one. 30 square divided by 50 square is equal to square root of this. This is the equation. So calculate the distance between both. So you get 552 and 58. Now cos theta is the adjacent for cos theta 1 and cos theta 2, because two lamps we have to inclined at the two different angles. So cos theta 1 you calculate adjacent by hypotenuse. So you get both cos thetas like this. Next, so the illumination at the point P due to lamp A, two lamps you are having. So they have given the CPs of the lamp. So here it is a 200 CP, it is 400 CP. So here illumination at the point P due to lamp A, that means CP is 200, d square you calculated, cos theta also you calculated, substitute all the values and calculate the illuminations. Okay, similarly, so illuminations at P due to B lamp, the lamp B. So E divided, this once again the same formula, all the values are calculated already, substitute in this formula, you will get the lux. Illumination is equal to 0.0606 lux is the illumination. So next, total illumination is illumination from the A and illumination from B. So if you add the illuminations from the lamp A and from the illumination from the lamp B, you will get the total illuminations at the center of the point. Okay, so it is 0.817 lux. So this is the illuminations at the center of the, that is total illuminations from both the lamps. Okay, right. Next is next another type of problems. A room of 20 meter into 10 meter is to be illuminated by the 8 lamps, and is average illumination is to be 50 lumen per meter square. If the utilization factor is 0.48 and depreciation factor is 1.2, calculate the MSCP, means empirical candle power per lamp. So the area of the room is given. Area of the room is 20 into 10. So it is 200 meter square. Okay, this is the area of the room, 200 meter square, it is 20 into 10. The total luminous flux required is, total luminous flux is area of the room into number of lumens. Okay, the average illumination. So it is the total illumination required is the area into number of lumens. So it's equal to 10,000 lumens. Okay, next the total lumens given after allowing all the factors. Okay, so by 8 lamps, let us consider 8 lamps. So they are given right, 8 lamps, right? 8 lamps they have given. So the total lumens given out by 8 lamps, how much lumen that is given out? That is lumen into depreciation factor divided by utilization factor. Utilization is given, right? Utilization factor is given, depreciation factor is given. So this, if you substitute utilization and depreciation factor in the formula, you will get 25,000 lumens is the output. Okay, then total lumen per lamp, this is the lumen given out by all the 8 lamps. Okay, now you have to calculate the total lumens given out by each lamp. So it is 8 lamps we have used, 25,000 divided by 8, so 3,125 lumen is the lumen given out by each lamp. So MSCP per lamp is lumen divided by 4 pi. So the equation MSCP means spherical candle power is per lamp is lumen divided by 4 pi. So lumen, how much you got? 3,125 divided by 4 pi. So you'll get 248. So it may be approximately 250 candle power. So MSCP is 248 candle power. Okay, so this is how you have to calculate the different parameters in this particular type of the problems, right? Okay, this is the similar type of problem. This I'm not going to solve now. So similarly, it says share the PDF, you can just go through that particular problem. These are the similar type of problems. Yeah, this is one different problem I have that we will solve now. Okay, it is required to provide a illumination of 100 lux per meter square or candela power in the factory hall of 40 into 10 meters square. Assume that depreciation factor is 0.8 and the coefficient of utilization is 0.4. The efficiency of the lamp is 14 lumens per watt. Calculate the number of lamps required and the disposition. So you have to calculate how many number of lamps are required for this particular specifications and the dispositions, how you have to position them in that particular hall. Okay, so area of the factory is given 40 into 10. So area of the 40 is 40 into 10 is 400 meter square. So the total lumens required is 400 into 100 is they have given here. So the provide the required illumination they have given here, it's 100. So that is why, so 400 area into required illumination is 100. So you'll get the 40,000 lumens is the total lumens required. Okay, next lumen given out by the lamp. So it is lumen into depreciation factor divided by utilization factor. So depreciation factor is less than 1, then waste light factor is equal to 1 if not given. So depreciation factor is less than 1 they have given, so neglected. So waste light factor, if they are not given, you can consider it as 1 also. Then it is 40,000 lumens is 40,000 divided by 0.4 they have given, and utilization factor is they have given 0.8. So depreciation, as it is a less than 1, you have to neglect it. So you'll get the total lumens is 1,25,000 lumens. Okay, so the total wattage required, how much they have given? 14 watts, 14 lumens per watt. So then total wattage is given, it is 1,25,000 divided by 14, it is equal to 8,930 watts. The total wattage required is 8,930 watts. So let us consider if 300 watt lamps are used. We can say it's, you can use a 400 watts also, 500 watts also. Just I am taking it's 3. If the 300 watt lamps are used, then how many numbers? So the total wattage you calculate it. Okay, so the total wattage you calculated here. So this is the total wattage. So if 300 watt lamp used, how many number of lamps means, that is 8,930 divided by 300. So you'll get 30 number of lamps. So you can use the 400 lamps. So then 8,930 divided by 400, you'll get different number of lamps. Okay, so 30 numbers are there. So 30 numbers is positioning 30 lamps in the particular area is difficult. So let us consider the list little bit higher value. So we are taking 32 number of, this is number of lamps we calculated. So we have to dispose them in the given area. That is why, so the 30, if you are considering 30 number of lamps, so they are disposing equally in all the area is difficult. So that is why you can, I'm taking it is 28 you can take, or 32. So I'm taking, so for the more illumination purpose I'm taking 32 number of lamps. So 32 number of lamps you just consider here. Disposition means, so how much is the area? It is 10 into 40, right? Okay, 40 into 10 meter square. This is your 40, okay, and 10. Now your 40 into 10, so just equally you have to distribute them. How many number of lamps you have? 32 number of lamps. 32 number of lamps means 8 lamps horizontally, in 8 lamps horizontally you have to place here, and 4 vertically. So 8 into 4 is 32. So 8 should be in a horizontal plane, 8 lamps should be horizontal plane and 4 lamps in a vertical plane, so that all the lamps are equally distributed. Okay, so here it is the dispositions, and the you have to calculate the distance between each also. So the distance between this wall to this lamp should be 3.4 meter. So from this lamp to this lamp is 3.4 meters. So the distance between each lamp is 3.4 meters horizontally. So 3.4 into, you can multiply these numbers, you will get 40 meters. Similarly vertically, so here, so the distance between the wall to lamp should be 2.5 meter. So this lamp to this is 2.5 meters, this to this is 2.5 meter, that is 2.5 into 4, it is 10 meters. So equally you have to distribute the lamps in a given area. Then total number of lamps is 30. So if the 3 into 30 is 30 lamps are used, they will not be given the uniform illumination. That is why I consider 32. So 4 into 8, lamps can be used, so they will be given a uniform illumination. Okay, so this is how you have to dispose. So if they are asked in the exam, so number of lamps you have to calculate, then find the disposition also, then you have to find out like this. So you have to find out number of lamps required, and then you have to draw this diagram and indicate where you have to place all those particular number of lamps. Okay, that is the type of problem. Okay, next is a hall 30-meter long and 12-meter wide is to be illuminated, and the illumination required is 50-meter candle. Calculate the number of voltage of each unit and the location, and monitoring the height of the units taken, and the depreciation factor is 1.3, utilization factor is 0.5 given, and the output of the different lamps are given below here. So yes, similar disposition problem it is. So I think there is no need of solving it, the same problem which I solved here. So the different wattages are given, so for different wattages you have to find out the dispositions, and you have to show the diagram. Similar problem is there, you can see number of lamps you have to calculate first. Here for 28 bulbs, what is this one? Okay, so this is the disposition. Okay, that is why similar problem is there, so I will not solve. That's also similar problem. Same type of problems are there. You just go through the problems. If you got any doubts in these problems, you can feel free to contact me. So the PDF of this will be shared here along with you. So still, if you have any doubts in these problems, you can contact me. Okay, thank you.